What's up, graders? So today you're going to be learning about graphing linear inequalities. We've learned about inequalities before, right? Inequalities are greater than, less than, greater than or equal to, or less than or equal to signs. And so now we're going to plug in what we know about graphing inequal or equations and graphing inequalities, and we're going to do it on coordinate grids. This can kind of be difficult just because there's a lot of different pieces we have to remember, just like regular inequalities. But kind of pay attention, and I think you'll be fine. Let me know if you have any questions. And so let's kind of do some background, right? If you have a greater than or less than sign, you're going to have a dotted line. If you have a greater than or equal to or less than or equal to sign, you're going to have a solid line. This still falls true from when we're graphing linear inequalities on a coordinate grid. And so let's keep going. Choose a type of line for the inequality to be given. So if you have y is greater than or equal to 3x minus 2, since it's greater than or equal to, we will have an A solid line. Let's look at 2. Y is greater than 1/4 x minus 5 because it's greater than but not greater than or equal to. We will have a B dotted line. And then kind of challenge yourself here. If you have a dotted line greater than or equal to, less than or equal to, or less than or equal, or less than or greater than sign. Well, it's dotted, so we will have a less than or greater than sign. This one is a solid line, so we will have a less than or equal to or greater than or equal to sign or line. If an inequality is y is greater than mx plus b or y is greater than or equal to mx plus b, you're going to shade above the line. This is very, very important to remember. But anytime you have a greater than or equal to, you will shade above the line. If you have a less than or equal to line or sign, you will shade below the line every single time. All right. This is probably one of the more important pieces, so make sure you understand this. And so this practice, if you have y is greater than or equal to x minus 2, a lot of you get lost with the sign of greater than or equal to. But in reality, we can actually change that just to a y equals x minus 2, graph it, and then pay attention to what our sign is. So let's just graph it first. If our y-intercept's negative 2, we're going to have our first point at negative 2, and then our slope is 1 over 1, so rise 1, run 1, rise 1, run 1. And we'll get a line like that. And then we also know that we're going to have a solid line because it's greater than or equal to, because now we can look at the sign, right? Greater or equal to, and because it's greater than or equal to, and it's a greater than sign, we will shade everything above. Okay, everything above this line will be shaded. Let's look at another example. Y is less than or equal to x minus 2. Again, we can just make that y equals x minus 2 and graph it and then pay attention to the sign. So put a point at negative 2, up 1 over 1, and we get a line like this. It is a solid line again because we're looking at a less than or equal to. And because it's less than or equal to, we are going to shade everything below that line. Okay, everything below that line is shaded. And what this means is that anything below this line would fall true for this statement. Okay, we can pick any of these points below this line and it will become a true statement for this equation. Let's keep going. Do you think, did you do anything different when the line is dotted rather than solid? Do we do anything different? No, not really, okay? We don't do anything different based off if it's solid or dotted. So let's even look at this. Y is greater than x minus 2. So again, make that x or y equals x minus 2. But our line's going to be dotted this time because we're looking at a greater than sign and not greater than or equal to. And because we are looking at a greater than sign, everything above that line will be shaded. Okay? Hopefully this is making sense. It's really not too bad. Y is less than x minus 2. Again, we are going to set that into y equals x minus 2. And because it's a less than sign and not a less than or equal to, we will now have a dotted line. And because we have a less than sign, we are actually going to shade everything below that line. So everything below that line is a possible and a possible solution to this equation. So challenge yourself. If we have y is greater than negative 1/2 x plus 3, ask yourself, is it going to be solid or dotted? I'm hoping you're thinking it's going to be dotted, okay? And you'll get a line like this. It's dotted because it's greater than sign. And we are going to shade everything above because it's a greater than sign. Again, we can keep going. If we were to guess this, we can go ahead and just start with, well, it's a solid line, so it has to be greater than or equal to or less than or equal to. So A and C are out. And then it's shading everything below that line, so it has to be less than, which means A is our answer. We go ahead and watch the next video. I'm about to lose time.